Okay, guys, today inshallah we're going to continue what we started in this week. So we start talking about the lesson 2 of chapter 19. We're still talking about the electric current. So yesterday we know what meant by electric resistance and we know what meant by electric current and we know how to calculate the current intensity of electric current and what is resistance and what are the factors that could affect the resistance of a conductor. Yesterday we stopped at the part which is talking about the voltage, and we said voltage is the amount of energy that the source used to move one column of energy in a circuit. So as we said here, electrons to pass an electric circuit or the charge to flow in electric circuit, there is a kind of energy that push them, which is the electric energy, which is produced from the battery or even whatever the source that produce electricity. So this electric energy, it is the energy which makes the electrons of the atoms of the conductors push each other until they complete their path. So like this, we said that voltage is the amount of energy. So simply here we can say voltage equal that the amount of energy. So energy divided by the amount of the current or the charges that will flow. So Q. So V equal E over Q. E is the amount of energy that will allow one coulomb, that means quantity of electron. So as energy is measured in joules, okay, and the quantity of energy is measured in coulomb. So like this, the voltage unit is joule over coulomb, which equal the SI unit, which known as volt. So voltage is measured by volt, which represent the amount of energy needed to transfer a coulomb of electrons in a circuit. So here it simply represent that if you have a lot of voltage, okay, that means if the voltage increase, it means, okay, the amount of electrons that will pass will be more, okay. So in that case, okay, as voltage increase, the current will increase also. That's what we said yesterday. That means there is a kind of direct relation between the voltage and the current. That means as the voltage increases, the current will increase also, because that means the more energy where the circuit has, that means the more charge that will flow in a circuit, so that means the more current. Any hard question till that point, guys?
No, thank
Okay, so then here we said, okay, a circuit with high voltage source transformer electric energy to the other energy forms than the circuit with low voltage source. That means the high voltage circuit, it has a more current that flow in it, okay. So electric energy transforms to other form of energy in different all parts of the circuit, okay. So here let's find this. We could, that's me. During the electric current flow in the circuit, some of the electric energy will be transferred into thermal energy due to the resistance of the wire. And if we have loads, for example, the bulb, so some of this electric energy will turn into light energy. If we have, for example, a speaker, it will change this electric energy into sound energy and so on. So the amount of energy changes in different parts of the circuit. So that means if we need to measure the voltage, which means the amount of electric energy that pushes the electrons, I cannot measure the overall voltage, but I need to measure the voltage of a specific part of the circuit because each part has different voltage than the other. So like this, okay, we find that we use, okay, voltmeter, that a device, okay, which is used to measure the voltage, and this voltmeter is connected parallel to the part which we need to measure it. What does it mean? For example, here, this is the simplest electric circuit ever, just battery, wire, and the electric bulb or electric lamp. So here, like this, most of the energy of the electric energy is being converted into light through this bulb. So if I need to measure how much of the energy or how much of the voltage that is used by this lamp, I'm just use the voltmeter and connect it parallel to the lamp. So can I put, if I get this voltage and I connect it to the battery, is it gonna have the same reading? Of course not. It will not have the same reading because the amount of energy which is produced from the battery is different than the amount of energy that used by the lamp, because not all the energy is consumed, just part is converted into light while the other part of electric energy still making the electrons flow in the circuit, okay. So here, as you could observe, that the different reading, okay, as you can see here. So like that, okay, guys, we could measure the electric voltage, or we could measure the voltage by using voltmeter, and voltmeter is connected parallel to the part that we need to measure its voltage. Is it clear, guys? Or something not clear in that part? If cannot understand, please ask.
No, Mr. Thank you.
It's clear?
Yes.
Okay. So here like this, guys, we pass to the last part in our lesson. Before this, but just a little need to make a little comparison just to help us or to make it easier for us, okay? So we are going to talk about the current versus the voltage. So here we said that current, we said that it's in the amount of charge that flow in 1 second. Okay, and we said that this current, okay, is measured by measuring unit. We call it ampere. And we said it practically, if we want to measure a current in a circuit, we use a device called a meter. So a meter is a device that you used. Okay, a meter is used to measure the current. Okay, a meter is connected parallel. Connected in series. What meaning by connected in series? That we could put it anywhere in the main path of electrons. That means you could put anywhere in the wire of the circuit, because all the circuit have the same current. So it's not a big deal that wherever you put the meter in, it will give the same reading. Okay, so we call that the meter is connected in series. Okay, and we can calculate the current by using the law, which we know that I equal Q over T. Okay, so let's clarify the idea here. Like, for example, let's draw this simple circuit. Okay, so this circuit here, there is a current flowing in that circuit. Yes or no, guys? Guys,
Yes.
yes. So if I want to get current, I get a device. We call it a meter. We draw a meter like this. So once we make this, that means a meter. So if I put the ammeter here, okay, so that means I connect the ammeter to the circuit. It will give a reading, for example, 2 ampere, for example. Okay, so that is the current which passes in the circuit. So whatever the place you put the ammeter in, if I put the ammeter here, here, whatever, anywhere, okay, in the circuit, it will give the same reading because it's the current is constant, okay, or the current is fixed here while is flowing in a circuit. That's why we could use a meter, or we put a meter in series. In series, that means anywhere, okay, within the main wire of the circuit. But in the other hand, let's look to the other hand here once we talk about the voltage, okay? So once we talk about voltage, we said that voltage is the energy used to pass charges in a circuit, okay? So it's measured by measuring unit we call it volt, and it is measured by a device called voltmeter. So this voltmeter, okay, is connected in parallel. What mean by parallel? That means it's connected to the part which we need to measure the voltage, because the voltage vary in different parts of circuit. Connected in. So let's write here, or let's find the drawing, and we said that V equal E over Q. Okay, so that's mean if I have this circuit, as we just saw in the previous slide, this simple circuit, and I want to measure the voltage. Could I put the voltmeter here like this, guys?
No.
No, because actually voltmeter cannot be connected in series, because in series they're like this, okay, actually the consumption of the energy that is used, okay, or the amount of energy that used in the wire, okay, doesn't that match, so the voltmeter will not give that reading, because the reading of voltmeter here, it will not be accurate. So what we should do in that case, I should connect, that will be wrong, okay, so the voltmeter must be connected in parallel like this. Once I put the voltmeter here, the voltmeter is gonna read the energy that is consumed by the bulb, or that's gonna read the difference in energy before and after the bulb. You get the idea, guys?
Yes.
Yes, so like this voltmeter must be connected in a parallel. That means must has its own path or its own route, its own wire, okay, that will be connected to the main wire of the circuit. Is it clear here, guys? Guys,
Yes, thank you.
Yep. So now let's pass to the plus part in our lesson, the part okay, which is known as Ohm's law. The rewire science, his name is Ohm. Thus, Ohm find the kind of relationship between the voltage, current, and resistance. Okay, so he find that the resistance could affect the current, and the current also is affected by voltage. So somehow the voltage, current, and resistance they are related to each other. He figured out a mathematical relationship that could show the relation between these three variables. Okay, so as we said that here, as voltage increase, the current will increase, and as resistance increase, the current will decrease. So we end up by this law that the voltage equal the current multiply resistance, V equal IR. So like this case, we could find that the voltage, okay, equal the current multiply the resistance. That means if I have a resistance of a certain device and I know the current that passing in a circuit, I could figure out what is the voltage, okay, that the current, okay, need or that the circuit has. If I have the voltage and you know the current that flows, so I could know the resistance of the device or the resistance of the circuit. Let's take an example here, guys. So here I ask you, the current through a light bulb is 0.5 ampere and the resistance of the light bulb is 22 ohm. So what is the voltage? Who can answer this or try to answer this with me, guys? Let's find here. So here we have the current and we have the resistance. So that means we already know that I, the current equals 0.5 ampere, and the resistance R, it's equal 22 ohm. Yes, Hannah, let's find what is the rule.
I with R
V equal I multiply R. Okay, so simply, so like this, he wants to calculate the voltage. So V is the unknown. V equal, the current is 0.5 multiply 220. So 220 multiply 0.5, that equal 110. And what is the measuring unit of voltage? It's volt, which is V. Is it clear here, guys?
Yes.
Is it clear for everyone, guys?
Yes.
Okay, so let's check our answer here. Okay, so the I, as we said, is 0.5 ampere, while the resistance is 220 ohm. So the rule, which is have V equal IR, so finally end by 110 volts. Okay, so we are working good. So here, like this, guys, we find that Ohm's law, or the Ohm's law, simply, okay, it represents that I could calculate different physical quantities or different electrical quantities in a circuit by Ohm's law. That means if I know the V, I could and the I could find the R. If I know the R and the I could find the V. If I know R and V, I could find the I, and so on. So for example, here he asks you to calculate the voltage if you know the resistance and the current. So you could find the volt equal 5 volts here by using the rule V equal IR. Another example here, for example, here you know that the current equals 0.3 ampere, and you know that the voltage of the battery is 6 volts. That okay, so how much is the resistance of the bulb? So resistance equal V over I, so 6 divided by 0.3 equal 20 ohms. And here, if we know the resistance and we know the voltage, could you predict how much of the current that flow in this electricity? Yes, I equal V over R. So in that case, 12 volts divided by 50 ohms equals 0.2 ampere. Is it clear here, guys? Any other question?
No. No.
Okay. So like this case, we said that we can find that Ohm's law state that with equal current, the voltage is greater across the device with greater resistance. That means if the current is constant, the more resistance we have, the more current we need to allow the more voltage we need to allow the same current to flow. Okay, so like this, guys, we end our lesson. Okay, that was the last part of our lesson. I hope it's easy. Okay, let's try to answer the following question as a kind of practice. Which is the unit of electric resistance? We measure electric resistance in. Yes, Kenzie?
Will be C.
C, ohms, good, okay. The resistance is measured in ohm, good. Which term refers to the amount of energy the source uses to move one column of electrons through a circuit? That is the definition of, yes, Fadia? Yes, Fadia? I can't hear you. I think there is a... You can write in the chat, Fadia.
Voltage.
Voltage, good, yes. Okay, it will be the voltage, the definition of the voltage. Good. Last question. What property of a wire increases when it's made longer? That means if we make the wire longer, so what of these will increase? Yes, Judy?
C.
See, resistance, good. We said that long wires have more resistance than short ones. So like this, guys, that's the end of our lesson. I need you, I hope that you're gonna study it well from your textbook. So study it very well, and you could check your YouTube to find the recorded session, okay, for the online students. If you missed any part or something is not clear, you can write your answer, your questions, and I'm gonna answer you as soon as possible, okay? So any question before we end our meeting, guys? Also check your SMS, okay? You're gonna find there is worksheet too. So you're supposed to answer the section review or the lesson review in your textbook and answer the worksheet on the SMS. Online students, you send your homework through the mail on SMS, while physical students bring your homework in the class. So any hard question here, guys?
No, thank you.
Thank you, guys, and goodbye.